This video is on how to determine, without graphing, if a system of equations is consistent or inconsistent, and based on that, how many solutions are there to this system of equations without graphing. And I'm going to switch over quick before I look at a problem. I'm going to switch over to my paper here. I know it says without graphing, but it's very helpful to have a picture, idea, a pictorial image of what's going on in the problem. So there are three ways that our system of equations could happen. One way is the two equations, when graphed, are parallel, and that would be inconsistent. So that's an inconsistent system. Just by looking at the picture, we can see that they're parallel. How that helps us is if there's no solution, these two lines never intersect. They never cross. There's no point that they share, that they have in common. So there is no solution to an inconsistent system. Can't happen because they're parallel. Those two lines never cross. It could be that the two equations, when graphed, cross somewhere. Could be anywhere, but I just drew it like this, which means there's one solution. There's one point that they share, that they have in common. And that would be a consistent. Sometimes it's called independent, but I think they're going with consistent in this one. A consistent system, and there is one solution. You couldn't have, I take that back. You couldn't have two solutions with linear equations. If you have two linear equations, two straight lines, you can only have one. You could only have zero solutions, one solution like this where they cross at one point, or there is one other option. This is why I can't say there won't be more than one, but the third option is if you graph those two equations, one right there, if the other one falls right on top of it, if they're the exact same equation, they're equivalent equations, then there's an infinite number of solutions. They're always crossing. There won't be two or three solutions because the only way to make these two lines cross twice is if one of them curves, which would be a quadratic, and we haven't really talked much about that. Or if it crossed 2 times or 3 times, you'd have to have a cubic or a quartic or some other fun equation rather than linear. Okay, that's the idea. That's what we're looking for. I'm going to pull up a problem, and I don't really know the correct answer to this one, but I'm going to write it down, and then I'm going to solve it, and we're going to find out whether it is consistent, inconsistent, or if there's an infinite number of solutions. So basically, if there's no solution, one solution, or an infinite number of solutions. Here we go. There's a problem. Now, you could choose to use substitution to solve this. You could also choose to use the addition method or the elimination method. Either one is fine. There's no right answer to that. Because one of the variables is already by itself, because y equals something already, where y is already by itself, I'm going to choose substitution. Just because that for me, in my experience, if one of the variables is by itself already, substitution is the fastest way for me to get the answer. I know that y equals all this garbage over here. Y is the same as this stuff. In this first equation, instead of y, I'm just going to write that stuff. I'm going to write it over here just because I have more room. So I'm rewriting this equation right here, but instead of writing negative 2y, I'm going to write negative 2 times all this. So I've substituted in for y. minus 10x equals negative 14. At this point, I'm going to speed up a little bit because now we're solving a multi-step equation. There's only one variable, there's only x, so I don't have to worry about y anymore. I'm done with this for now, and I'm just looking at this equation here. So I'm going to distribute. We get 10x minus 14 minus 10x equals negative 14. I see that there's multiple x's on the same side of the equal sign, so I'm going to combine those together. 10x minus 10x, if I combine like terms, well, that's 0. 10x minus 10x is 0 x's. So I'm going to write negative 14 equals negative 14. Well, that's true. And that's always true. Negative 14 is always equal to negative 14. What we found is that no matter what you put in for x here, it doesn't matter what you choose for x. 5, if you put 5 in for x, this is going to be true. If you put 22 in for x, this is going to be true. If you put 52 billion in for x, this is going to work. This will always be true. No matter what, it's always true because these are the exact same equations. If you divide those by 2 and you rearrange it a little bit, you're going to get back to this again. So these are equivalent equations. There's one right on top of the other. They're the exact same thing. So there's an infinite number of solutions. And the way you can tell is that this is always true. No matter what, there's an infinite number of x's that you can substitute in here. This will always work. So if it's always true, it's infinite. If, when you do this process, if you solve for x, if you get, or y, if you get something like, 5 equals 7, that's definitely wrong. 5 will never equal 7. Or if you get something like 0 equals 4, nope, 0 never equals 4. That cannot happen. If either of these cases happens, there's no solution. So when you solve, if you get an answer that can't be true, there's no solution. It's inconsistent. If you get an answer that's always true, there's an infinite number of solutions. It's always true. If you actually get x by itself, you solve for x, you get an answer, x equals 5, x equals 0, x equals 7, x equals something, or y equals something. There is a solution. They do cross, and it's consistent. So basically, you either get an answer, x equals something, or you get something that can never happen, or you get something that's always true. Those are your 3 choices, and that's how you can tell which of these it's going to be. Let me know if you want more examples. I can walk through more examples, but I'm going to stop there. Well, let me see how much time I have. All right, I'll do one more. Let's do one more. What this one? Okay, I'm trying to decide, is it independent or dependent? So I'm going to write it down quick. I'm going to go through it fairly fast. 27 over 2x, take away 3y. Okay. All right, so I've got this. I want one of these variables to eliminate from each other. I'm going to be honest, the fraction is one extra piece that I don't really want to deal with. So what I'm going to do first is I'm going to eliminate the fraction. I'm going to multiply everything in the second row times 2. So the first row won't change. If you like fractions, go for it. I mean, there is nothing wrong with fractions. Secretly, I really do like them. But I know that I'm an oddity in that. All right, so I eliminated the fraction just by multiplying both sides of this equal sign times 2. Multiply everything times 2, no more fraction. I'd really like the, I guess it doesn't really matter. Let's make the y's go to 0. I'm going to use the elimination method, the addition method, because the x's and the y's are lined up. X's and y's are lined up with each other. If I multiply the first row times negative 3, and I distribute through the parentheses. So I multiply everything in the first row by -3. I'll go down here now. That first row is going to become 27x plus 6y equals 18. The second row I'm going to leave the same. You might be able to see what's going to happen here. 27 minus 27 is 0. Do the addition method. 27, 0, 0, 0. They're the exact same equation again. So I picked another one that happens to have an infinite number of solutions, because 0 always equals 0. Doesn't matter, 0 will always equal 0. And so this is not consistent or inconsistent. Do they use the term, maybe I should check and see. Oh, sorry, it's dependent. That is a word that they chose to use for this. Independent would be consistent, so sometimes they throw extra words in there. But this one would be dependent, not independent. Independent would be consistent. And dependent would be infinite. So they're going to go back and forth, it seems, with these two words, independent and consistent. There you go. That's how you do it.